I just bought way too many switches. In this video, we're gonna figure out why each of these is so different on the inside so that I can choose the right one for today's project. Hey everybody, AJ here, and welcome back to the Eagle Ray channel where we do all things DIY electric boats. Marine motors, batteries, solar panels, you name it, if it's got volts and it's on a boat, you are in the right place. Today, we are going to talk about all the switches that exist. I can't tell you how many times I've ordered a switch on Amazon, only to find out when it showed up in the mail that it's the wrong type of switch. It's happened to me so many times, and today I've got a bit of an oddball switch that I need. I need a switch that can power on this box, and there's something very special inside this box. I've actually been working on something top secret, some skunkworks R&D for the Eagle Ray channel, and I've been working on it for 6 months, and it's almost ready. We're not going to be able to look at it in detail today, but we're going to get a sneak peek at what's in this box at the end of this video, after we figure out which switch is the best one to provide power to this box. This isn't grade school, so rather than spend a bunch of time on boring key terms, let's just play around with these switches. We're gonna plug them in, see what they can do, and we'll figure out how they're different from each other one at a time. For example, this is an SPST switch, this is an SPST switch, and this is an SPST switch. They all look so different, and yet internally they're practically the same functionality-wise. And check this out. This is an SPST switch. This is a DP-DT switch. They look practically identical, yet they couldn't be more different. So how in the heck would you ever tell which one's which just by looking at it? The truth is, you can't. And that's why switches are so confusing. Unless somebody shows you how to test what's inside the switch without cracking it open, you're never gonna know what type of switch it is. And there's two things you really must know before you go plug this in. You need to know how many poles it has, and you need to know how many throws it has. And it's not that useful for somebody to just give you the answer to that. That's not gonna help you when you found a random switch in a drawer in your garage and you're wondering if it's the right switch for your current project. So how do you figure that out on your own if you've got the switch right here in your hand? Let's talk about poles first. Poles are the hard part. They're the part that everybody gets wrong. For example, I count 5 pins on the back of this switch, and I've seen lots of YouTubers say that this is a 5-pole switch, and that is dead wrong. This is absolutely not a 5-pole switch. This is a 1-pole switch. Lots of people confuse pins with poles because pins are on the outside and poles are on the inside. So when you press here, that causes this paddle to shift that way. That causes this pole to move that way and contact the top of that pin, so that now you have it already touching here and now it's touching there too. That completes the circuit in this direction. And then if you press this button, then it does the exact opposite on the other side and completes the circuit there. So if all you see is these 5 pins, you have no way of knowing if there's 1 pole, 2 poles. There could be any number of poles and you just don't know because you can't see inside the switch. But rather than break the switch open to find out, what you can do is test it. And to do that, you've got to use the most important tool in your entire electrical arsenal, the multimeter. Remember, if you want to work on boats, you have to stay away from the Klein CL390. This is the common one that you'll find at Home Depot. This one can do AC only. It might look identical to the Klein CL800, but if you look close, there are different items on these dials. This one can do DC current clamping. This one cannot. This one works on batteries. This one doesn't. Link in the description for this one. In order to figure out how many poles are inside this switch, we've got to use the continuity setting on our multimeter. So we're going to take the dial and switch it to the, I believe it's the 4th setting here. The little Wi-Fi symbol means continuity, and all that means is that we can test for a metal-to-metal connection through any object. So metal-to-metal could be just the probes touching each other will give you a beep, or any piece of metal between the probes will give you a beep, and that'll help us determine if there's a pole inside this switch, because if there is and it's touching any pair of these pins, then we can just test each of the pins and we'll get a beep if there's a pole. Oh, and there we go. So when the switch is on, there's only 1 pair of pins that beeps. I've tested this extensively, so I know there's no other pin pair except these 2 that beeps on us. And so that means that behind just this pin pair, there's a pole on the inside, and it's the only pole in the entire switch. So even though this one has 3 pins and this one has 5 pins, they're both exactly the same on the inside. They can each support 1 complete circuit here and 1 complete circuit here. You can't send 2 hot wires through this one. You can't send 2 hot wires through this one. They each support 1 hot wire. That's what single pole means. But if this is a single pole switch, why does it have so many extra pins? It's because switches don't have to have all the same type of pins. In the case of this 5-pin rocker switch, only 2 of these, the ones on the bottom left here, are the switch pins, and then the rest are for lighting up LEDs in a number of different ways. These rocker switches are the most popular type of switch you'll ever find on a boat, and that's why I want to spend some time going over all the variations of how you can wire these pins. Because if you look for a tutorial for how to wire these on YouTube, you'll find a bunch of different wirings, and every single time they'll tell you this is the correct way, when in actuality, all they're showing you is the way that they were taught, and they often don't necessarily realize that there are a lot of different ways that are all correct. There's actually 6 different ways you can correctly wire this switch, and I've never seen a YouTube video that shows all 6 of them. So this video is going to be the first that shows you every single variation that's possible. Let's go. First, let's get these grounds out of the way. It's really easy to do the top 2 pins. You can just jump them across, and then you need to send this to battery minus. Now, the magic happens right here on these 2 pins. We saw how they go hot together when you turn the switch on. So these are going to be where all of the action is between the battery and the load. Because really all we're trying to do here is control whether or not this wire is hot. And so all we have to do is break that right in the middle, and we can send one end of it into one side of the switch like this, and the other end into the other side like that. Or we have 2 different options here. We could go BL. The other way to do it is to go this way. LB. If you ask anybody in the boating world, they'll probably tell you to wire this switch in the BL configuration. But if you talk to an auto mechanic, they'll probably tell you to go with the LB configuration. So which way is better? Whether you go BL or LB here doesn't matter to the battery or the load. Either way, they will both work exactly the same. When you turn the switch on, they'll connect. When you turn the switch off, they'll disconnect. And that's true for BL and LB. So don't ever let anybody tell you that one of these is better than the other. They're just options. So what difference does it make then? Well, the LEDs behave differently when you start switching these things around. So we're going to look at every single variation that you can possibly get out of these LEDs. For example, if you want the top LED to always be on, which is option 1, then you need to wire this LB. If you want the top LED to be on when you flip the switch on, then you need to wire it BL. And the reason that changes is because this top LED is actually connected to this pin right here. And so if you put battery straight onto that pin, that LED is automatically just going to be lit up all the time. Whereas if you put the battery on this pin, then that LED can't light up until you close the connection between these 2, and then it'll light up. That's where you get option 1 and option 2 here. Notice that LED on the top doesn't have an option 3 always off because it's sharing the switch pin with at least the battery or the load. You don't have a third option there. Whereas with the bottom LED, that one is connected to this pin, which means you have the choice to not connect this pin at all, and that's what gives you option 3. So if you count up the number of variations here, because you have 2 LEDs, you'll find that there are actually 6 options that you can go with in total. Because you can do 1 and 1, you can do 1 and 2, you can do 1 and 3, or you can do 2 and 1, you can do 2 and 2, or you can do 2 and 3. So let's really quickly just draw a quick diagram of all 6 of those options. Here's 1 and 1. This is what it looks like. LB, jump from the B. Option 1 and 2 is LB, jump from the L. And option 3 is easy. All you've got to do is remove the jumper. As long as there's nothing touching this pin, the bottom LED will be always off. How about option 2 for the top LED? In order to go to option 2, we have to switch from LB to BL. Now we can go always on just like before by jumping from the battery. Same thing again. If we want 2 and 2, then we have to keep what we had with BL and jump from the load instead. And then if we want option 3, then we just have to not connect anything to the pin on the right. We're about to demonstrate every single way you can wire this switch, but before we get into it, let's just look at the configuration a little bit because this might look a little confusing compared to the way you'll do it on your actual boat. So first off, we've got a black jumper pin across both of these grounds. This is the ground for the LED on top, this is the ground for the LED on bottom, and both of these just need to go back to battery minus, which is what we have on this green wire here. So we're just going to clip that onto the ground. So we don't have to worry about the top part of this switch anymore. It's really just what's going on the bottom here. This is either going to be B or L, or sometimes we switch those. And so I left these two pins exposed because I want to be able to swap them quickly. You wouldn't necessarily set it up quite like this on your boat because you don't need to swap these all the time like I'm about to when we go through the variations. Same story on the other side. Normally you would just have one jumper here over to this pin on the right. But because I'm going to be jumping through every variation of how to wire this, I need to be able to use this one in some of these cases, and I need to be able to use the other one in other cases. So that's why there's two of them there. Now let's jump into each of these variations because as we saw, every single situation is going to be different based on how you combine these LEDs. The top one can be always on or on when the switch is on. The bottom one can be always on when the switch is on, or always off. And so you can do 1 and 1, 1 and 2, 1 and 3, or you can do 2 and 1, 2 and 2, 2 and 3. That's your 6 variations. So let's look at the wiring for each of those one at a time. Let's do 1 and 1, always on and always on. And by the way, we've got a little LED to stand in for your load. Whatever this ends up being that you need to turn on, it could be a fish finder or an aerator pump or whatever. We're just going to have a little LED light up to represent the load. So this is L. This is B, and we're going to wire them such that we can have always on, and that's going to require us to do LB and then jump from the B. So we're going to put the L on the top pin, we're going to put the B on the bottom pin, and then we are going to jump from the B. And we're going to jump it over like that, and then always on, always on. Notice when I flip the switch, the load turns on, but the LEDs don't change, whether it's on or off, because they're both set to always on. So that's variation 1-1. How about variation 1-2? Let's try it. It's pretty easy to switch it. All you got to do is swap out this jump from the B, switch it over to jumping to the L, like that. And then you have top LED is still always on, bottom LED has gone to on with the switch. So as soon as we flip this, then the bottom LED comes on and off again. And then the last one is another variation of the bottom LED. You have this option, or you can just have it always off by removing the jumper. And that way you still have always on top, and then you just have no LED active on the bottom no matter what. So that's the third variation. That's this and this, this and this, this and this. Now we can do this and this, which is 2 and 1 on with the switch versus always on. Let's see what that looks like. To get to option 2 on the top LED, we've got to swap the B with the L. So instead of LB, it's going to be BL now. So we're going to bring the L down to the bottom pin. We're going to put the B on the top pin. And then we're going to jump from the B in order to be always on. So we're going to take the B, which is on the top pin now, plug it into that jumper. And so now we have on with the switch on the top. See, it comes on when the switch is on. And then we have always on the bottom. That's 2-1. Now we're going to do 2-2. Just like before, it's quick to switch between this one and this one. All you got to do is swap out that jumper. You take the B jumper out and you put the L jumper in. And that gives you on with the switch, on with the switch. They both turn on with the switch. And then last but not least, you need option 2 and option 3. On with the switch on the top one, always off on the bottom one, and just like before, you pull the jumper completely untouched in order to not use the bottom LED. So those are your 6 variations. I do think that one of these wiring options is the most correct way to wire these switches, and this is totally my opinion, but I'm going to tell you why. It has to do with the purpose of these LEDs. Why do these LEDs exist? The LEDs are obviously here to give us information, but the problem with the bottom LED is that it's not very good at giving information. It's so tiny that it can really only tell you one of 2 things. Is it on or is it off? That's it. And so because that's all it can do, that's all you should use it for. So you use it to tell whether the switch is on or off. That's it, it's easy. Whereas the top LED is much more complicated because these usually get sold with a sticker book. So you can take one of these stickers, put it on the backlit large LED on top, and now you have a differentiated icon for every single switch in your multi-gang panel. And that is especially useful in the dark. Picture yourself using your switch panel in the dark. If none of these lights were on top, then you wouldn't be able to tell which one is which, and you might turn on the wrong one. So the LED on top should always be on, because otherwise you would hit the wrong switch all the time. The best way to wire this switch, in my opinion, is top LED always on, bottom LED on with the switch. If you wire it my way, that's LB, jump from the L. This is how you get the best use out of these LEDs. And if you're not going to put these LEDs to their full use potential, then you may as well have bought the version of the switch that doesn't have LEDs, because they make that one too, it's just not as popular. Imagine my frustration whenever I look at one of these multi-gang switch panels on Amazon and find that they are always wired wrong. I can't even believe it. They don't take full advantage of the LEDs most of the time, but that's just where the problem starts. So we're going to have to do a whole other video to figure out how to fix the wiring in these multi-gang panels. Even though these rockers are the most popular switches you'll ever see used on a boat, these are not going to be sufficient to run what's in this box, because these are single pole switches and I'm going to need more than one pole to run what we've got in this box. Before we get into switches that have multiple poles, let's talk about throws, because every switch has at least one pole and at least one throw. Sometimes they can have more than one of each, but they'll always have at least one of each. So when you look at a product listing and they list the number of poles, they'll usually list the number of throws right after that. So what the heck is a throw? Throws are pretty easy actually compared to poles, because poles are on the inside of the switch. You can't see what they're doing, but throws are visible on the outside. All it means is how many on states do you have. So if you can throw this switch into only one on position, then it's a single throw switch. And if it has two on positions, then it's a double throw switch. So that's pretty obvious. These rocker switches only have one on position. On, off. So that's why we call them SPST, single pole, single throw. Compare that to a single pole double throw switch, which has two different on states. You can throw this one on upward or on downward. And it is still a single pole because they're sharing the pole. If you turn one of them on, it grabs the pole away from the other. So it's an either or situation. Turning one of them on requires the other to be off. If you've done any kayak or small boat mods, you may be familiar with these cheap Amazon PWMs that have a forward and reverse switch attached. This is an SPDT switch. It's single pole, double throw. So now when the switch is in neutral position, we shouldn't get any beeps on any of these pins, from yellow to black or from yellow to red. Doesn't matter, no beeps. But when we throw the switch in one direction, I believe that will give us, yep, a beep on yellow and red, and then if we throw it in the other direction, it'll give us a beep on yellow and black. There we go. So we've been over the two most common switch types, SPST and SPDT. There's two more we got to get to, but the next one is fairly rare. It's super useful every once in a while when you need to turn on two different appliances that are completely separate from each other, but you need to turn them both on at the same time with one switch. You do that with a DPST. That is double pole, single throw. DPST switches always have 4 pins on the back. You can see there's a pair on the left, a pair on the right, and those pairs do not cross each other. This is 2 separate circuits under one roof. So basically it's a pair of SPST switches working together that you can turn on both simultaneously by flipping one switch. That's why a DPST is very convenient for replacing a couple of SPSTs. Imagine you have a system where you've got a couple of the same component and each one of them came with an on-off switch, and you don't want to have to flip all of those on-off switches individually, so you just cut them out of the equation. You wire both of them into a single DPST, and then you can turn both of them on at the same time by flipping one switch. Now, this is your biggest hint as to what's going to be in this box when we do the reveal at the end of this video, because this is a very common component that this switch attaches to. If you've watched some kayak mod videos on YouTube, you may recognize what this switch goes to. If you can guess what's in this box based on what you see here, leave me a comment down below with your best guess. Okay, the last switch we're going to look at is very similar to the DPST. This one's called a DPDT, double pole, double throw. We'll look at the similarities first. If you flip around to the back, you can see they both have 2 columns each. The columns actually match up with the number of poles in both of these cases because each one of these columns is a complete circuit. Every circuit has to have a pole on the inside controlling it. So that column has a pole behind it, that column has a pole behind it. There's 2 poles there. Same thing here. This column has a pole, this column has a pole. Double pole, double pole. So that's where they're similar, but they differ on the front side with the number of throws. So this one we saw has only 1 on state, so it's a single throw. This one has 2 on states. You can throw it on upward, throw it on downward. It has 2 throws, so it's a double pole, double throw, DPDT versus DPST. The DPDT has 6 pins on the back, and that's the most we've seen on any switch so far, but it does get way more complicated than that. You can have 3 poles, 3 throws, 4 poles, 4 throws. You can have any number of poles and throws, and the pins just keep stacking up. But it gets a little bit excessive unless you're an electrician once you get past a DPDT. So the DPDT is probably the most complex type of switch that you're ever going to want to use when you're doing DIY work on your boat. And it turns out there's something very specific that a DPDT switch can do really well, and that's to send a motor from forward into reverse and vice versa. Check it out. Now you might be wondering, we saw a PWM earlier that had an SPDT switch that was doing forward and reverse also, but you have to be careful with that because an SPDT cannot do this by itself. On that PWM, the SPDT was being helped by relays to get that job done, but a DPDT switch can do this forward-reverse job all by itself. And we're going to learn exactly how to wire this up in next week's video. We're going to look at it in a lot of detail. All right, we've looked at all the switches, so it's time to reveal which switch we need to power up this box. You may have guessed it from the hints I dropped earlier. The switch that we need is the infamous DPST. This switch is capable of powering 2 separate circuits simultaneously. And why do we need 2 separate circuits? Dual thrusters, why not? Check this out. I promise those are spinning very fast, it's just a frame rate issue. And now, the big reveal. There's a lot going on in this box, but the thing that we're looking closely at today is these 2 speed controllers on the end are turning on because we added a DPST switch. So if we flip one switch, both of these come on and power the rest of this stuff at the same time. We don't have to worry about what this other stuff is. This is a custom-built circuit board that I've been prototyping for the past 6 months. We're going to see a lot about this on the channel in the near future. These rocker switches are the most common type to use on a boat by far, so you should probably have a few on hand in case you need them. But as we saw, they're not always the right switch for the job. So if you ever have trouble remembering the difference between SPST, SPDT, DPST, and DPDT, say that 5 times fast. Don't even worry about it. Just bookmark this page and YouTube will remember everything for you. Next week, we are going to be building custom aluminum brackets for stow and deploy of this custom dual motor setup that I'm building. And that's going to be a lot of fun. So if you want to see that, make sure you're subscribed. Make sure you hit that notification bell. Otherwise, you're not going to get the notification the moment that video drops. And join us for the live stream on Sunday because we are still giving away this Milwaukee angle grinder if we can get 100 people into the chat this Sunday. I hope to see you there. And until then, I hope you set aside some time to get out on the water before it gets too cold and have a little fun. Until then, boat safe, take care.